Hello, and welcome to Most Significant Bit, a podcast that explores the connections between engineering, technology, humanities, and the arts. I'm Kenny, and today we're discussing self-healing materials inspired by biomimicry. In this episode, we'll explore how nature inspires innovation, specifically through the development of self-healing materials. These materials are designed to repair themselves after damage, much like how living organisms heal wounds. We'll walk through the science behind how they work, the breakthroughs that made them possible, and how they're being used today in fields like construction, aerospace, and electronics. Let's explore how biomimicry is shaping the future of sustainable materials. Imagine this. You drop your phone, and instead of the screen cracking permanently, it just heals. Or a concrete bridge develops a small fracture and seals itself before anyone even notices. That's the power of self-healing materials, and it's all based on ideas borrowed from nature. Let's start with the basics. Biomimicry is the process of learning from and mimicking strategies found in nature to solve human problems. Nature has had millions of years to test and refine solutions, so it makes sense that engineers and scientists look to it for inspiration. And one of nature's most incredible abilities is healing. Think about it. Our skin can repair itself after a cut. Trees can seal wounds in their bark. Even lizards can regrow their tails. These natural healing processes have inspired researchers to develop synthetic materials that can detect damage and fix themselves without any outside help. So how do these materials actually work? Let's break it down into 3 stages: discovery, evaluation, and exploitation. Discovery. This is where scientists first look to nature for ideas. Researchers studied how living systems repair themselves, like how proteins rebind, how cells regenerate, or how plants form scar tissue. They asked, can we build materials that do something similar? This curiosity led to some fascinating possibilities. For example, mussels use special proteins to stick to wet surfaces. Scientists realized these proteins can be mimicked to create self-healing adhesives. Evaluation. Once they had ideas, the next step was testing. Scientists began developing materials like polymers or composites with special healing abilities. Some use microcapsules that break open when damage occurs, releasing a liquid that fills the crack and hardens. Others use reversible chemical bonds that reconnect after being broken, just like Velcro reforming after you pull it apart. There are also materials that respond to heat, light, or even pressure to trigger healing. For example, certain plastics can be warmed up slightly, and their molecules will shift back into place, effectively healing small scratches or dents. It's kind of like giving the material a mini reset button. Exploitation. This is the real-world use. Self-healing materials are now being applied in all kinds of industries. In construction, special types of concrete contain healing agents that react with water and air to seal up tiny cracks. That means longer-lasting roads, bridges, and buildings with fewer repairs. In aerospace, engineers are developing aircraft parts that can repair minor damage mid-flight, improving safety and reducing downtime for inspections. Even in consumer electronics, researchers are working on phone screens and cases that can recover from everyday scratches, perfect for anyone who's ever dropped their phone on the pavement. And it's not just limited to solid materials. There are also self-healing coatings, fabrics, and paints. Imagine a car paint that can fix its own chips after a gravel hit, or a jacket that repairs small tears on its own. So, why is this such a big deal? First, it makes products last longer, which means less waste. That's huge for sustainability. It also improves safety, especially in things like bridges, airplanes, or pipelines, where small cracks can lead to big problems if left unnoticed. And over time, it can save a lot of money by reducing the need for maintenance and replacements. What's really exciting is how this field continues to grow. Scientists are now exploring living materials, like engineered bacteria that can detect and heal damage in their environment. It's like giving buildings or devices a basic form of life, or at least the ability to take care of themselves in small ways. Today, we covered how self-healing materials, once science fiction, are now becoming reality thanks to biomimicry. Nature continues to be our greatest teacher in building more sustainable and resilient technology. Thanks for listening.